All right, good morning. Just so you're aware, I am going to record this. It should only be about 5 or 6 minutes. Uh, that way, whoever's not here, I can just post the quick video. So what we're looking at today are potential and kinetic energy problems. Um, the assignment's only 15 points. I'll have to update that. But here are the problem. Here is the problem set here, and I'll go over that in a few minutes. And just so you know, you do not have to do pages 3 and 4. I'm going to have to clean that up too. I'll just delete those. Couple of quick notes. I graded your lever problems, so those are in there. Some of you might want to relook at that. I do believe some of you took advantage of this here that I posted. So this is a great one on the levers in the human body. So I think some of you made use of that to help you through that second page. You just want to revisit the page that had the 7 examples, because some of you went awry there. The other one is the electrical reading that you did, and you submitted the questions tomorrow. We're going to have a discussion going over some of those questions. It would be in your best interest to watch the video, because on Thursday you'll have a short quiz-like assignment looking at simple machines, levers, that reading, and a couple of these potential and kinetic energy problems. All right, so if you remember when we went through our notes, when we came back, or I think about 2 weeks ago, we looked at energy, and specifically 2 types, potential and kinetic energy. Remember, potential energy is the energy of gravity, or it's stored. So again, if you're up on a hill, you possess a certain amount of potential energy due to your position, or hypothetically, if you're a chemicals in your body store energy in their molecules. All right, and then kinetic energy is energy of motion. Sorry about that, I was just getting situated here. So here are your equations here. So potential energy, again, is going to be the mass times the local gravity times the height. I always use the designation PE. This worksheet is just using E with the little p. Doesn't matter. The bottom line is you need mass, gravity, height. Then again, since potential energy is a type of energy, remember your units. So energy is in joules, mass is in kilograms, gravity is a type of acceleration, so that's meters per second squared, and then height would be in meters. The second equation you would use is kinetic energy, which again is energy of motion, so again, that's going to be in joules, and the equation is 1/2 the mass times the velocity squared. Remember, velocity is meters per second, again, which is different than meters per second squared. All right, so those are the equations. You can go ahead and look through. Again, you've got a worked out equation here. We'll go ahead and just look at a couple of problems, and then we'll get you on your way. So what is the potential energy? So right away, again, we know we're looking for that of a 2 kilogram, so that we know that that is a mass that is on a 1 meter high plant stand. So we know our height is 1 meter. The one thing that's not given here, which is implied, since it's not stated otherwise, is we know our local gravity is 9.8 meters per second squared. So then we just plug it all in, right? So our M is 2, our G is 9.8, and then our height was 1. So basically you can see this one here is going to wind up being 2 times 9.8, which is going to be 19.6 joule. Do not forget your unit. Right, so there's 1. So 1's done for you. And then what you're going to look to do then, so I had 1 through 11 here. So you're going to wind up doing 2 through 11, which are 10 problems, and you're only using those 2 equations. So that is the assignment. I'll go ahead and post this real quick in case you're not paying attention. But other than that, we'll have that discussion tomorrow on the reading. You'll have a little short quiz on Friday, and then or Thursday, and then you'll get your review on Friday. So other than that, I'll keep the stream open for any questions, but have a good day.